A word on myself. I've been in the transit business for 25 years. I've represented several manufacturers during those years, and recently was contacted by Proterra. And when I put this presentation together, basically what I did, when I went to see the bus, and I was so impressed with the bus and what they did and how they did it, and the reasons why I think it's such a superior product, it convinced me to leave the job that I had and join the Proterra team. I'm happy that I did that. So basically, the reasons that I am about to show you why I think the Proterra bus is such a good product and what its place should be in the marketplace is the same reason that I took the job. Why Proterra? It's an advanced electric bus technology using lithium titanate batteries. Quick charge, less than 10 minutes for a full charge. And as Dale explained, basically the principle behind this bus is, depending on your route, depending on your service, as Dale said, we had a 30-mile run yesterday, and we started out at 83% charge, and we ended up at 43%. We prefer to say that we have a range of 30 miles, but in that term, 30 miles, basically if you're running a route that you say is 15 miles and you come back to your center, your bus would pull in, if you chose to do it that way, depending on how you set it up, your bus would pull in under the charger. The brochures here will show you how that works. The charger then controls the bus. It sets down on the bus while you're offloading and loading. There's no effort to the driver. There's no interruption. There's no inconvenience to the passengers. And so let's say if you went 15 miles, basically that charger would set down on the top of the bus, and within the charge time, that 15-mile range, in 5 minutes you'd have a full charge. So basically from the customer it seems rather seamless, because what they're going to do is do their offloading and loading. By the time anyone realizes it, the dash indicates to the driver that you have a full charge. The charge mechanism deploys, goes up, and the bus drives right off again. So basically you've just filled your tank without any interruption. The bus is American-made in Greenville, South Carolina. Payback versus capital cost. We'll get into this a little deeper, but obviously we have to justify the difference between a diesel bus and a diesel hybrid bus and a CNG bus and the cost of an electric bus. It's a quality bus. It's all composite. I have a sample here of what the bus is. If you cut the body open on the bus, that's it. So it's an all-composite body. It's extremely strong and lightweight, and it's a true value investment. Capital cost versus where is the payback? Well, if you look at just the maintenance, the fuel, and the life cycle cost, well, let me back up a second. Let's take a diesel bus, and let's say a comparably equipped diesel bus at $450,000 would mean that for another $200,000 to $250,000 you're going to have the same bus with an Allison hybrid package. Then you jump another $200,000 roughly, and you're back into our bus. So basically those would be the steps. And for our bus, part of the savings would be you have no engine. So with no engine, you have no oil, you have no filters, you have no fuel, you have no belts, there's no turbo, no starter, nor other expensive and labor-intensive common replacement maintenance items. So if you take that out of that bus over a year or 12 years, that number is just huge, not to mention the infrastructure you have to have for it and what you have to do to support that product. As Dale mentioned about braking, you know, in one of the demos that Dale and I did together, a customer said that they're doing an average brake job on their fleet at 18,000 miles for an air brake bus. So you figure a brake job like that would probably, depending on drums and labor and materials, you're probably looking somewhere at $2,500 to $3,000. Over how many times before they'd have to do that? And we're looking at anywhere of 4 times plus. We would expect to get easily over 100,000 miles on our disc brakes on our Proterra bus. It's typical to have a midlife overhaul on your engines and transmissions, and many of the transit properties have that scheduled in. So that's a cost of roughly $35,000, $45,000 to rebuild the drivetrain. And if it was hybrid, if you added the hybrid option, The midlife battery replacement comes in, and that's estimated to be, and there's numbers been thrown around, between $30,000 and $40,000. So now you've added a hybrid to your bus. Well, it comes at a premium, and you still have a cost of the battery replacement. So I took some numbers and put them together, and what we have is, based on 30,000 annual miles at 4 miles to a gallon, at $4 per gallon, would be $30,000 annually for fuel. Based over 12 years, that's $360,000 worth of fuel. So now you take the no engine, and you take the brakes, for example, the maintenance, and that would be just your fuel savings. So I brought it to 40,000 miles. I mean, everyone's service is different. We have 4 miles to a gallon, same formula. At $40,000 annually for fuel, you would save $480,000 over 12 years going to an electric bus. Again, current hybrid technology. I sold a lot of hybrid buses with my previous manufacturer I represented, and it was a premium of $200,000 to $250,000 over a diesel bus. And the average, with a lot of the big fleets that I represented, I'd always ask them what they're getting for mileage. And basically, they were getting 1 to 2 mile per gallon increase by going to a hybrid bus. So you've invested in the premium of $200,000 to $250,000. You still have the midlife battery replacement. And basically, what a lot of fleets told me was they went from 3.6 to 4.8. So that was what they got from the fuel economy. So in the life cycle cost, you're not going to recapture your initial investment with that. CNG is averaging between 2.8 and 3.0. That seems to be a good number nationally. And Proterra, as we said, was rated at Altoona at 22 mile per gallon equivalent. Some of the features and benefits of our product. Again, the batteries are lithium titanate, so they are able to accept a quick charge as opposed to lithium ion. Less than 10-minute charge for a full range, and that again is if you drive that bus all the way down to the point where the indicator on the dash is telling you that you've pretty much exhausted the energy in the bus, it's going to take you 10 minutes to get a full charge. The lithium titanate is capable and designed for over 10,000 total discharge cycles, and we estimate it would take up to 20,000. Typical lithium ion is about 2,500 total cycles. No interruption in schedule, allowing for all day and night service. As you saw, some of the earlier customers were running about 18 hours a day. We ran 496 miles in one day at the Altoona test, and of course, again, it's all relative. If your schedule allows for you to revisit the charge station within 30 miles, you can continue to run this bus constantly. The batteries are integrated into the floor for better stability and center of gravity. Our bus is unique in that design. Some of the other manufacturers are looking to come out with electric buses, have them in the rear engine, what we'd call the engine compartment. They have them on the roof, and they have them in the passenger compartment. So basically, no batteries in the passenger compartment or on the roof. 1 battery replacement over the life of the bus compared to 2 or 3 for competitive models using lithium ion. Well, that's because we have we can accept so many total discharge cycles with the lithium titanate. So basically, you're going to replace the batteries on our bus 1 time during its life. And with the lithium ion, you're going to replace those batteries 3 to 4 times, and the cost of that per replacement. And it's estimated, I mean, battery pricing right now, it's come down a lot, but what we're looking at is, it's estimated for the amount of batteries you have to have on a lithium ion bus, there's a lot more batteries. So what you're looking at for cost replacement is probably in the $200,000 range plus for the lithium ion, and then you'd have to do that 3 to 4 times during the life of the bus. And we're estimating that by the time our batteries should last a minimum of 6, probably 8 years, and by the time that would happen, we're expecting for the lithium titanate batteries to run somewhere around $80,000. So if you added all that up, to have our bus with the lithium titanate compared to lithium ion, savings is huge. Again, the lithium ion batteries require 2 to 3 replacements during the life of the bus. That is a picture of our body. That's the way the body comes in. It is a one-piece composite body. It's fun to look at. The whole bus, everything is designed into the floor. It comes in one piece. If you plug the holes, you could put a propeller on the back of it and drive it away and put it in the water. All composite body. It's extremely durable. It's non-conductive. Crash worthiness, which offers incredible passenger safety. And another manufacturer who has since discontinued composite bodies because they were building them out of the country, I saw that bus and it went through a crash test. So they took an old 4-door Buick and they smashed into the side of the bus at about 30 miles an hour. And basically what it did was broke the skin on the exterior of the bus. You really couldn't tell on the interior of the bus that it had been involved in a crash. And repair on this bus, I mean, a typical steel or aluminum bus, you would have had a lot of ancillary damages. Your uprights, all your panels, and wherever that energy would have displaced into the bus with that type of an impact, you just don't have that on a composite bus. You have reduced maintenance on the bus, on the body. You have extended life from 12 to 16 years, and beyond that as it relates to the body. No worry of rust or corrosion whatsoever. Lightweight. Let's not forget, it's also zero emission. So that's the story. That's why I made the change. That's why I think other people should make the change. And I think we can go take a look. The charge stations right now, the cost is relatively $600,000 for a charge station. That charge station, depending on your route, depending how you have your buses set up, would be one charge station could take care of 6 to 10 buses. Obviously, you don't want the buses behind each other waiting to charge, so how you cycle those buses would go into the charge station. Now, Proterra, when I first was introduced to Proterra a little bit, a couple of years ago, I heard they had a $1.2 million bus. And basically, since that time, the bus cost has come down to roughly somewhere between $800,000 and $900,000, depending on what you put in the bus as far as surveillance, electronics, and things like that. So the bus has come down dramatically. We also expect for the charge stations over the next couple of years, because of economy of scale, getting better at what we do, having suppliers become more friendly to us, we're looking to have the charge stations down somewhere around $300,000 to $400,000, and that would take care of 6 to 10 buses.
We use between 170 and 200 kilowatt hours of energy in an 8-hour period of time. We recapture between 70 and 90 kilowatt hours of energy due to regen braking when you're doing a central business district cycle, which is start, stop, start, stop, start, stop. That's phenomenal. That's phenomenal. That's 35, you're recapturing 35% of the total energy that you have used during an 8-hour shift.